Procedure again today with a very important and also interesting question in system of particles. Okay, let us see what is this question is all about. A moving projectile explodes into several identical particles. Okay, that is the topic. Question is, a projectile of mass capital M is equal to n into small n, moving with velocity v0, explodes into n number of identical particles each having mass n. That means total mass is a capital M is nn. That is what we wrote. The kinetic energy of the fragments become eta times, eta is greater than 1, times eta times the original kinetic energy due to the energy released in the explosion process, and the maximum possible speed of any one of the particles. Possible maximum speed, because this is a n-body problem, so our aim is to maximize the speed of any one of the particle so that the kinetic energy, total kinetic energy becomes eta times the original kinetic energy. Okay, so this n is number of identical particles into which the projectile is broken. This is a kind of this type of question asked in Irodov. Say n is equal to 3. It breaks into 3 identical particles, but we will make it any number, but identical. So let us solve this. Let us solve this problem in the center of mass reference frame. Why center of mass reference frame? It has a big advantage. Since the total momentum of the system of particles remains 0 in the center of mass reference frame, it is easier to solve in the COM reference. Okay. Okay. So let us first write the kinetic energy of system of particle in the ground frame. That is K is equal to half m total into Vc square. M total is capital M, which is Nm. Vc is the velocity of the center of mass, and K, this symbol is kinetic energy with respect to the center of mass reference. So K of center of mass plus K relative to center of mass will give you the K in ground frame. But Vc is equal to V0 because given in the question. This projectile is moving with V0, so velocity of center of mass, when that is single projectile, it was V0 only, so that remains V0. Center of mass, velocity will not change at the explosion type because there is no external impulse. Okay, so Vc is V0 at the explosion. K initial is half capital M V0 square, that is half Nm V0 square with respect to ground frame. K after explosion eta times that, eta into half Nm V0 square with respect to ground frame. K with respect to center of mass reference frame will be how much? Of course, after explosion. How much? The K after explosion is equal to ground frame minus half m total Vc square. That will be kinetic with respect to center of mass. That's what I wrote. So eta half Nm V0 square minus half m total is capital M V0 square. But m is Nm, capital M is n into small m. So that what I wrote. So eta minus 1 half Nm V0 square. This is the kinetic energy with respect to center of mass reference frame, and this is, as I told you, this is after collision. After explosion. Let me write this so we should not get confused. So let us denote the velocity of these particles with respect to center of mass reference frame as u1, u2, u3, etc. Okay. This is U1, U2, U3, etc. up to UN. Let us say, because the question has to maximize the velocity of any one particle. Let's say particle 1, there's no loss of generality branding any particular particle 1. Let particle 1 possess the maximum speed with respect to center of mass reference. But he's asking respect to ground. First I am calculating, let us calculate the particle, let us calculate the maximum possible speed for a single particle in the center of mass reference frame. After that, I will add the center of mass velocity to that to get it from the maximum velocity possible in the ground frame. That's what I am going to proceed. So with respect to center of mass reference frame, let's calculate the maximum possible speed of any particle. Let's call that particle 1. P naught is equal to P net. Net momentum with respect to center of mass is 0. That's why the center of mass reference frame known as zero momentum reference frame. That means n with identical poly, all are having small m mass. U1 plus U2 plus U3 up to UN is 0. 0 vector. So U1 must be equal to minus of U2 bar plus U3 bar plus UN bar. Okay. U1 is the, if U1 is the maximum possible velocity of that particle 1, for increasing the kinetic energy by eta times, the kinetic energy increase by eta times. So for that U1 is the maximum possible velocity of particle 1. Then U2, U3 should be as small as possible in magnitude. Yes or no? The maximum possible velocity. And kinetic energy is a fixed value now, eta into initial kinetic energy. So this gets maximized. This half mu1 square gets maximum, that is the maximum. Then other velocities should be as small as possible, should be less. Okay. So U1 max will be minus of U2 bar plus U3 bar plus UN bar. From equation 3, I am directly writing this. When U1 becomes maximum, this becomes very small than U1, all of them, and that I can write here. I am not saying this is smallest or what, I mean they're smaller than U1. The magnitude of vector, because this U1 has to be maximum. So magnitude of vector sum of a set of particles U1 to UN, they are n minus 1 number of vectors. The magnitude of vector sum of these U2 to U1 vectors is to be maximized. So the resultant of U2, U3, UN, that is the vector sum, has to be maximized, and that should be equal to U1 max. That means when a set of vectors that I want to maximize, that sum I have to maximize, then they should be parallel to each other. Scalar addition give a maximum magnitude of the vector addition. So that's what I wrote here. U2, U3, U4, UN should be parallel to each other, so that their vector addition will be same as scalar addition. That will be maximum possible vectors, maximum possible value of the addition vector of this U2 to UN vectors. Because U1 is still maximum. U1 maximum is this much. So they have to be such a manner that their addition should be maximized. So they should be parallel to each other. And because of minus sign, there must be anti-parallel to U1. So they must be parallel to each other. Minus signs mean that the resultant also has to be parallel to each of them. I mean, minus sign says that resultant itself opposite to U1 max. Resultant opposite means all of them must be parallel. So all of them must be opposite to the U1. This is very important observation. So then from equation 3, equation 3 जो है U1, we can write U1 max is U2 plus U3 plus UN up to UN, because now I removed the vector signs, because the magnitude of this must be equal to magnitude of this, and they are the magnitude of, because they are parallel to each other, na? So this addition will be nothing but their magnitude, just the addition of their magnitude, because they are parallel to each other. So E1 magnitude is equal to magnitude of this scalar addition. Yes or no? Because they are parallel, anti-parallel to E1, and they are parallel to each other. So that's why I wrote in this manner. This is equation 5. To increase the kinetic energy eta times, E1 max must be some constant. Some constant E1 max. Because with this constraint that the kinetic energy eta times, okay, if kinetic energy eta times, then 1 second. Okay, sorry, back now. If you see, if kinetic energy has to increase eta times, then it must have a particular value of E1 max for that. Call that as a constant C1. Okay, so that means U2 plus U3 plus U4 up to UN should be equal to C1. C1 is that value of E1 max, which have the kinetic energy eta times. Okay, am I clear? So kinetic energy, you see, eta times, for that E1 max must be some particular value that called as C1. Okay, so half m E1 square plus half m into U2 square up to UN square is eta minus 1. Half nm V naught square, that is from equation 2. Equation 2 is this. This is the kinetic energy with respect to center of mass. So this is the kinetic energy with respect to center of mass. This is this. So half m you cancel from both sides. So U1 square plus U2 square up to UN square summation eta minus 1 into n into V naught square, which is constant. Then if we bring to E1 to this side, then also this, because E1, to maximize E1 square, because I want to maximize the E1 square. E1 I want to maximize. So E1 square also to be maximized. That means this, the right hand side is a constant. E1 is maximized means this U2 square up to UN square, the summation should be minimized. That's what I do. It's a very simple argument. So when U1 is maximum at C, the E1 max must have one particular value, let it be C1. So even E1 max is a C1 value is C1 for satisfying the given energy condition, the eta times increase. So U2 plus U3 plus U4 up to UN, which is the magnitude of E1 max, that should be C1. Yes or no? This is, that is the U1 max. When U is equal to U1 max, I told this is the value. So then if U1 max is C, then this vector sum also, this sum of the scalar sum also C. So that's what I wrote. So if E1 is, when E1 is maximum at C1, the satisfying the given energy condition, E1 is maximum, and we call that value of C1. Then U2 plus U3, U4 plus U1, which is E1 in magnitude, is equal to C1. To minimize U2 square plus U1, U3 square up to UN square. Why I want to minimize? Because I want to maximize U1 square. So this has to be minimized. So now how we can minimize? This is a very important one. Just look at this. U2 square plus U3 square up to UN square is U2 plus U2, that is the the u2 plus u3 plus u4 up to un whole square is u2 square plus u3 square plus u4 square up to un square plus 2 into all those u2, u3, u2, u4, u2, u5, u3, u5, u3, u4, like this will go on. So then this term is this square term, and bring it to this side. You write this as 4 and a half. So this, but 4ab, 4bc, 4ca, all this we can write as u2 plus u3 whole square minus u2 minus u3 whole square. This is 4u2 u3. Similarly, 4u2 u4 is u2 square, u2 plus u4 whole square minus u2 minus u4 whole square. Like this I go on writing. So that means equal to this u2 plus u3 u4 whole square, u2 square plus u3 square plus up to un square is u2 plus u3 plus up to un whole square minus this term half u2 plus u3 whole square plus u2 plus u4 whole square, like all those whole square term, and minus half u2 minus u3 whole square. That is the, you just open the bracket, minus half u2 plus u3 whole square plus u2 plus u4 whole square plus like this, then plus half u2 minus u3 whole square plus u2 minus u4 whole square, like this. Just open the bracket and write. This becomes plus, this becomes minus. So minus common, so this. So now you tell me, I want to minimize this. Minimize, this is square whole square term. This is a minus term, that will make it minimum, and this is a plus term, that will increase. So to maximize this, sorry, to minimize u2 square up to un square, this I cannot do anything, that is the sum of all these magnitude square. But here, what should I do so that it will be minimized? I have to make this term 0. Okay, so that it become minimum. So therefore u2 square plus u3 square plus un square up to un square will be minimum when this third term becomes 0, and that minimum value will be this. So the last term of the right hand side is 0 to minimize u2 square plus u3 square up to plus u4 square up to un square. So this 0 means what I should, each term should be 0, each square term should be, because they are all positive, some addition 0 means each individual term should be 0. So this u2 minus u3 0, u2 minus u4 0, u3 minus u4 0. So like this, u2 is equal to u3 is equal to u4 is equal to un. So that u2 minus u3 0, u2 minus u4 0, u2 minus u5 0, u3 minus u4 0, u3 minus u5 0, u4 minus u5 0. So all of them are equal in magnitude. So two things we've proven, that if u1 is the maximum, then u2, u3, u4 all are anti-parallel. They are parallel to each other but anti-parallel to u1. So they are moving back, and each of them are equal in magnitude. This is also, these two things we have observed. So from equation 5, 5 में आज क्या लिखे हम, a लिखे, u1 max is this in magnitude. So u2, u3, u4, each of them will be what? This is n minus 1 u2. The addition, how many terms will be there in 5? You all are equal in magnitude, I just found out. So it is n minus 1 u2, because 2 to n means n minus 1 term. So n minus 1 u2 is u1 max, n minus 1 u3 is u1 max, n minus 1 u4 is u1 max. So that's what I wrote here. N minus 1 u2 u1 max, n minus 1 u3 u1 max. So now if this is clear to all of us, then we can write then we can write with respect to center of mass reference, what is the KI? half m u1 square max and n minus 1 half m u1 max by n minus 1 whole square, because u2 how much? u1 max by n minus 1 whole square. Half m, that square is the k of particle 2 in Xiom reference frame. So like all are same kinetic energy because same speed. So n minus 1 into half m v2 square v3 square, all these would same as u1 max by n minus 1. Okay, so that becomes half m u1 max square plus un max square. If you take common, this is 1 plus 1 by n minus 1. So n by n minus 1 half m u1 max square is the kinetic energy of the particles in center of mass reference. And from equation 2, what I wrote with respect to center of mass reference frame, the kinetic energy is eta minus 1 half nm v naught square. Okay, equate that to here. Equate that here. N by n minus 1 half m u1 mass square is the kinetic energy with respect to center of mass, but that is also equal to eta minus 1 half nm v naught square. So cancel कर लेंगे n half half. So u1 square u1 max will be root over of n minus 1 into eta minus 1 into v. Yes or no? That's very nice. The equations. So now my problem is solved. This is the maximum possible speed of any particular particle in center of mass reference. Then with respect to ground, V1G with respect to ground will be Vcm plus U1 max. Okay, so V0 plus U1 max. To maximize V1G, Vcm and U1, Vcm and U1 max must be in same direction, must be parallel. So V1G maximum will be V0, just scalar addition of these two. V0 common 1 plus root over of eta n minus 1 into eta minus. Yes or no? Because V0 take common. That's the answer. Fine. Numerical example लेते हैं. V0, that projectile velocity initially 500 meter per second. So V0, let us call it 500 I cap in x direction. It breaks into 9 identical parts, so n is 9. Kinetic energy increased by 50%, means it becomes 1.5 times. So eta is 1.5. So V1G max how much? Put the values 500 into 1 plus 9 minus 1, 1.5 minus 1 root over. That's what we wrote. So 500 into this is 8 into half 4 root over 2, 3. 1500 meter per second will be V1G max. So 1500 I cap. U1 max will be how much? U1 max is just above this. We wrote U1 max. This, that is n minus 1 into eta minus 1 root over into V0. Just put those values. 9 minus 1, 1.1. So this is 2 into 500. That is 1000 meter per second. 1000 I cap. U2, U3, UN वो कितना होंगे? Very simple. ये हमने आपको बताया. U2, U3, U4 will be U1 max by n minus 1. N is 9 minus 1 8. U1 max by 8. So U1 max by 8. So 125 meter per second. Which direction? Opposite to U1 direction. All those U2, U3. So this is U2 bar, U3 bar, UN bar, all 125 minus I cap. So what is V2G then? V2, U2 is this with respect to center of mass. U is with respect to center of mass. So with V is with respect to ground. So V2G will be, VNG will be how much? V0 plus U2. V0 plus U3. That is 125 minus I cap plus V0 is 500 I cap. So that is 375 I cap. So that means the speeds of all the small particles will be speeds of all those particles from 2 to n will be 375 meter per second. But still I cap direction, all are moving in I cap direction. The only one, the maximum possible velocity 1500 meter per second, that is one. The others are moving 375 meter per second. So that's what I read. But all in और ओरिजिनल डायरेक्शन ऑफ मोशन। इरोडम में क्या दिया है, n की 9 की जगह 3 दिया है, ब्रेक्स इनटू 3 आइडेंटिकल पार्टिकल्स। सो काइनेटिक एनर्जी ईटा इज 1.5 उसने भी दिया है। So you can now solve that. Instead of 8, instead of 9, you can put n as 3. You put n as 3, so 2 into 0.51, so it will be V0. Eta E1 max will be V0. That will be 500 only. So then this will be 500 plus 500, 1000 will be the, with respect to ground, it will be 1000. If it is 3, I made it 9. Okay, so you see, we have made a more general case here compared to what Irodov has asked. I think you must have understood the argument. Okay, so there are two arguments here. If one is having maximum velocity, or all others must be try to be as minimum as possible, so that the kinetic energy remains only one eta times greater. Okay, that cannot be violated, and momentum should have to be conserved also. So what's this conservation of momentum? I did that conservation I did from center of mass reference frame. That's all. So from center of mass reference frame, the energy I wrote in equation 2. So then I solved the whole problem center of mass reference frame. Okay, so all of them should be as small as possible, but this is the crucial point. To minimize this square, there has to be, since their sum is constant, this u1 plus u2 plus u3, x1 plus x2 plus x3 up to is a constant, then x1 square plus x2 square will be when both all of them are equal. That's why I've proven here mathematically to minimize u2 square plus u3 square un square, because u1 plus u2 plus u3 is minus, that is u1 magnitude, that is c1, which is a fixed value for that particular case of energy increasing to eta times. Yes. Whatever that value, call it c. That means this also become constant. So this variable sum is constant. So to minimize the squares, the sum of their squares. This is constant. So I'm minimizing their sum of their squares. That will be possible under condition when they are all equal. That's what you can take some numerical values and check also. So that's, then I found that they will be minimum when the sum of the squares will be minimum when the last term of the right hand side, this term is 0, means when they are all equal, u2 to un, they are all equal in magnitude. That's it. So we have arrived at a very, very important result. Don't get confused. This is n minus 1 into eta minus 1 root over into v0, that is u1. Then just add the v0 to it to maximize it with respect to ground. That's it. Very simple. Okay, I think all of you are clear in this, and it's a very good question. Thank you all. And this is a very fundamental question. This is a very conceptual question. I'll be happy if you understood this. Go through these arguments again and again, so that you get a clarity in your mind. So similar questions I'm going to deal regularly nowadays, and come regularly to my classes. Subscribe if you have not, and try to raise your difficulties, doubts. My credentials are given here. So bye for today. Best of luck to all of you for your upcoming exams. Thank you all.